afternoon. This is the final lesson in the surface area and volume section for 3D figures. Today we're actually going to do volume. And I'm going to walk through all the figures we did surface area for again, starting with prisms and cylinders. You'll see why I put these together in a moment. Pyramids and cones, spheres, and finally what are called composite figures, which means a combination of these things. Okay, we're going to start with volumes of prisms. Okay, so volumes of prisms and cylinders. Okay, so the volume of a prism, in general, start with there, is simply the area of the base times the height. I'll give you an example of that. I'm going to draw a prism, a rectangular prism in this case. Oops. That was a bit off. And that's behind. There we go. Okay, the area of the base is, here's the base down here. Area of a base, let's make it 4 by, looks like about 3 by 5 inches. The area of the base in this case is 12 square inches, 4 times 3. And what you're doing to get a volume is simply stacking these little 12-inch areas on top of each other until you get to 5 inches. So it makes a certain amount of sense that the volume would be 4 times 3, which is the area of the base, times the height, which is 5. So in this case, 12 times 5, or 60 inches cubed. Remember to put the right units on that. So again, area of base, remember the base are the two parallel parts, times the height. And that is all there is to it. For a rectangular prism, it's just going to be length times width times height, because the area of the base for a rectangle is the area of the rectangle, which is just length times width. So it's just length times width times height. But the general form you should just think about is area of base times height. Before I give you a couple problems on this, recognize the base is not the bottom. And I'll do it with this example here, and then one that's a little more important that you make that differentiation. So base is not the bottom. In this case, I made it the bottom, but it doesn't have to be. This could have been the base. Remember, the base is just two parallel parts. So this is parallel to that, and it's the same shape, it's the same polygon. Therefore, I could call that the base. Then the area of the base is simply 5 times 3, or 15 square inches. And then I have to take for the volume of the prism, I have to take that 15 and multiply it by 4 to get 60 cubic inches. In other words, it didn't matter which one I took as the base in a rectangle. However, if I have a little trickier problem, so let me erase this and make a triangular prism. We did this one back when we were doing surface area. There we go. Looks like a little tent. In this case, the volume is still, it's a prism, so the volume of the prism is still area of base times height. However, the base is the triangle. It's not what you would consider to be the bottom. It's the parallel part. So if I put some dimensions on this, like this is 6, and that's 5, and this is 12, which I think is the same dimensions I used last time. And say that's the same, so it's a prism. Then the base is actually a triangle, right here, of height 4. And you can find that by the Pythagorean theorem. 5 squared minus 3 squared is 16, square root of that is 4. So that's 4. So the area of the base is 1/2 base, which is 6, times height, which is 4, or 12 square inches. And then I have to multiply that 12 square inches, times the height, which is 12 inches, and I get 144 cubic inches. That's my volume. So again, important to know which one is the base. The base is, again, not the bottom, but the parallel parts. Okay, before I give you some problems, I'm going to do a cylinder at the same time. The reason I do a cylinder at the same time is it is the same formula. So if you draw a cylinder here of radius r and height h, we'll make it a right cylinder again. So this is the height this is a right angle. If you do that, the volume of a cylinder is simply area of base times height again, which area of base is a circle, so it's just pi r squared times height. And that is, make sure you write that down, that's the volume of a cylinder. However, you don't really have to remember that, you just have to remember area of base times height, because the circle is just the area of the base. Okay, before going on to the next section, I'm going to give you a couple examples. Let's start with let's make a square prism. Let's make a square prism. There we go. I'm going to put some dimensions on it. 4 centimeters. 4 centimeters is a square times 12. Let's make it 15 centimeters deep. Okay, so what I want you to do is find the volume of that. Okay, pause the video. All right, if you're back, I'm going to pick, I'm sure you probably picked the 4x4 as the base, but I'm actually going to pick this one as the base. I can do that because this is parallel to this. So if I do that, the area of the base times the height is 4 times 15 is my area of my base, which is 60 times 4, or 240 cubic centimeters. Hopefully that's your answer. I suspect most of you did 4 times 4 for this base, and then multiply it by 15, but you get the same answer. Okay, let's give another one. Do a cylinder this time. Radius is, I don't know, 10 feet, really big cylinder. And the height is, I don't know, it's like 25, say, feet. Okay, I want you to find the volume of that cylinder. Pause the video. All right, if you're back, it should just be area of base, which is pi r squared, times the height, which is 25. So that's 25 times 100 times pi, or 7,854 cubic feet. There you go, hopefully you got that. Okay, before going on to the next one, just to talk a little bit about volume, why do you care about the volume of this? Remember I said that, for example, this is a common storage mechanism, tin cans, garbage cans, things like that, and you have to know how much it fits. This is how much it fits, how much stuff it fits. Same thing with a prism, a box. Amazon probably spends a good chunk of time figuring out exactly how much volume can fit in a given box so that they know what box sizes to buy for the amount of stuff they sell. Okay, we're not going to do the next ones, which is pyramids and cones. And again, you'll see why I'm linking these. Remember, the surface areas were slightly linked as well, that you had to find the slant heights for pyramids and the slant heights for cones in order to find the surface area. Volume is related in a similar manner. Okay, so volume of a cone, I'm going to draw one. First I'm going to draw a pyramid before I do the volume. That's a really poor one, anyway. And let's see, that's fine. Okay. Remember that the height is the perpendicular height. If you're given the slant height, you'll actually have to find the height in case of volume. And let's make this a, let's call this is the base down here. Just to put some numbers on it, I'll say this is 4 feet by 5 feet, and the height looks bigger, so let's say it's 8 feet. Okay, so what is the volume of this pyramid? This is a little less relevant than the first ones, because I don't know why you would care what the volume of a pyramid was, unless you were an ancient Egyptian. But let's go through it. The volume of the cone is a little more useful. So, first of all, it still has the same form, which is area of base times height, although it's not a prism, so it's clearly less than that. If it was a prism, this whole rectangle on the bottom would be on the top as well, and it would be a lot bigger. The answer is actually 1/3 area of base times height. Why it's a third is actually really hard to calculate. Again, it takes calculus, but I will come back to that in a couple of years when you take calculus. Okay, similarly, I'm going to draw a cone now over here. In this case, you want to know how much ice cream you can put in your ice cream cone, volume of it. So let's make it the size of an ice cream cone, like, I don't know, a couple centimeters deep, or radius, and a height of, I don't know, so is that like maybe 10 centimeters? That's a decent sized ice cream cone. The volume of that, the volume of the cone, is also area 1/3 area of base times height. That's because you can see they're very similar. The only thing you have to then put in is what is the area of the base, which is pi r squared height. So the area of the base is pi r squared. Okay, so there you remember, right there, make sure you write that down and that down. So it's just like the prisms and cylinders, except you just have a third in front of both of them. All right, I'm going to now give a couple problems on that. We'll start with a cone. I didn't even calculate the one we had before, so let's just use, we didn't do the volume of it, so we're going to do that now. And in fact, if you didn't erase it in your own notes, which you probably didn't, you could just use that. So let's take a radius of, what did I say, 2 centimeters, and a height of 10 centimeters. Okay, so tell me what the volume of that ice cream cone is. How much ice cream can you fit in? Pause the video. All right, if you're back, volume is just 1/3 pi r squared times height. 1/3 pi 2 squared times 10, which is, what is that, 40/43 pi. And let me get the actual number for that. Looks like 41.88 cubic centimeters is how much ice cream you can fit in that cone. Okay, let's try another one. This time I'm going to do a pyramid. I'm actually going to do, nah, it's a little tricky for this. I'll just do a simple rectangular pyramid. Okay, let's make it 6 feet. Let's make it like the Egyptian pyramids. 1,000 feet. And we'll make a rectangular Egyptian pyramid. 800 feet. And the height, let's make that, oh, I don't know. Actually, what I'm going to do is I'm going to give you the slant height. So let's say the slant height is also, let's say it's 1,200 feet. Okay, so what I want you to do is to find the volume of that pyramid. Pause the video. Okay, if you're back, volume of the pyramid is 1/3 area of base times height. I don't have the height. I do have the area of the base. It's just 800 times 1,000. To find the area of the height, I just have to find this height here, h. This distance here is half of 1,000, which is 500. Oops, no, I've gone the wrong direction. Because I don't actually, oops, that's 1,200. No, I can do it this way. Yeah, that'll work. It's fine. So this will make this 500. And then that h squared will be 1,200 squared minus 500 squared using the Pythagorean theorem. Square root of that, 1,200 squared minus 500 squared. And then square root of that. 1,091 feet, rounded. Okay, now I've got my height. I can go out and find my volume of the pyramid, which is going to be absolutely huge. And so area base will be 1,000 times 800 times the height, which is 1091. And that gives me 1,000 times 800 times 1091 divided by 3, or 2,909,33333. Let's put the right decimal ones in there. 1, 2, 3, 4, 6. Yep, 290 million feet cubed. There we go. Can fit a lot of dead old Egyptians in that. All right, we're going to move on to spheres now. Spheres. Remember, the surface area of a sphere was 4 pi r squared. you can imagine that still a volume is still going to have r in it because it's the only dimension you have. It's more like an egg than a sphere. Oh well. Add a little bit in that. And a little better. Okay. So the volume of this is going to have r cubed in it. It has to. There's only one dimension, and it's got to be three-dimensional. It also has a pi in it because it's circular. Then it has, strangely, a 4/3 in that, which again, unfortunately, I'm going to have to punt showing you where that comes from until calculus. But that is the volume, 4/3 pi r cubed. Okay, so make sure you got that right written down. That's a sphere. So let me just give an example. If I put 2 inches in there, really tiny sphere, like that big around, volume of the sphere will be 4/3 pi, 2 cubed, that's 8, times 4 is 32/3 pi. And we get that value. 33.51 cubic inches. That's how much I can fit in a little globe like that size. All right, that's a sphere. Pretty straightforward. I'm now going to summarize the formulas before we go on. So we had prisms and cylinders. We had pyramids and cones. Then we had spheres. That's it. So volume now rather than surface area. Volume of these will be area of base times height. And this will be pi r squared if it's a cylinder. Volume of these will be 1/3 area of base times height. And area of base will be pi r squared if it's a cone also. And then finally a sphere is 4/3 pi r cubed. There we go. That's all we have to know from this section. Okay, I'm going to do a couple of problems just of composite figures. And this is figures put together. I'm going to start with an actual ice cream cone. So I'm going to erase this. So these are called composite figures, and you'll see why in a second. Composite. Composite just means putting together. So I'm going to draw a cone, ice cream cone, and in the top of it, I'm going to put the actual ice cream. So my notes have a nice little actual cone there. Okay, and the height of the ice cream cone is 13 centimeters, just the cone part of it. And the width up here is 6 centimeters. Okay, so how do you do composite problems? You break it into 2 parts. I've got 2 parts of this. I've got the cone itself. There's 1. And then I've got the blob of ice cream on the top. 2. Okay, so if I want to find the total volume of this, I'm going to find each of those individually. Let me start with the cone. Volume of the cone is 1/3 pi r squared times height. The only thing we have right now is height, which is 13. However, this here, the 6 centimeters, tells me the diameter of this half circle on the top is 6, and therefore the radius is 3 centimeters. So the volume of the cone part of this is 1/3 pi 3 squared times 13. Or, let me get that number. That's 9 divided by 3. That's 39 pi, looks like. Or 122.5 cubic centimeters. That's, cubic centimeters. That's the volume of the cone part, so that's 1. Now I'm going to do 2, which is the volume of the sphere part, which is actually a half of a sphere. So volume of what's called a hemisphere. First of all, it's the sphere part, which is 4/3 pi r cubed, but then we just have to have it. So that is 2/3 times pi times r, which is 3 cubed, which is 27, or 56.55 cubic centimeters. So there we go, we got 2 of the pieces. Now if I want a volume total, it's simply volume of 1 plus volume of 2. Just add these 2 numbers together. 122.5 plus 56.55. And that gives me 179.1 cubic centimeters. There we go. So again, back to this, you'll have a series of composite figures, I think, in the next homework. Just break it into individual figures that you can find them using our basic formulas, and then add them up when you're done. And that's it. Okay, now homework. Homework for this lesson is it's volume, and there will be, geometry first. You'll be a volume worksheet for geometry. For AGO, it's a volume worksheet as well. Plus, I've got a series of problems over 2 different sections, so let me write those down. Challenge problems. These, by the way, are on your syllabus, hopefully you still have it. Page 724, 43 and 44. And page 732, 37 and 38. Yes, that's right. And then the SAT problems are again on page 724, 46 through 49 all, and page 732, 39 through 42 all. Here we go. Quite a few extra problems here. That's all for this lesson. Until next time. Thanks.